The animation of the terrain at the Sansparilla Road entrance into the Longleaf subdivision in Oakland, Orange County, Florida, is shown in the form of an interactive 3D model to explain the sources of surface water flow, which pooled in the cemetery on Sept. 27, 2020. This is a fully interactive 3D terrain model of the Oakland Cemetery, adjacent to Sansparilla Road and the Longleaf, at Oakland Subdivision, Orange County, Florida. The terrain data was collected by the United States Geological Survey in December 2018 to Jan 2019 after the Longleaf subdivision was completed. It shows the location of the cemetery relative to Pond 31 of the subdivision and Sansparilla Road, which is very small in extent, compared to the overall drainage basin which flows to the cemetery. This shaded area shows the total limits of the Pulte development, which can potentially contribute runoff to the cemetery. The image contains the watershed which drains to the cemetery and the State Road 50 drainage flow directly into the cemetery entrance on the west side. The Commonwealth Commercial Center is on the east side, and its pond is shown next to the Pulte Pond 31, and they are separate. The Commonwealth Pond discharges onto the Pulte property and then flows south to SR 50, where it continues to the west to the cemetery. The old raised railroad grade to the north of the cemetery acts as the limit of the rainwater runoff and is well defined. The railroad grade was constructed in the 1880s and is now abandoned. It forms a high embankment which is the north boundary of the watershed. Cemetery 3 also flows south, but it does not go through either pond, but runs through the space between both ponds. It is important to note that the Pond 31 did not overflow during the Sept. 27, 2020 storm event, and the water in the cemetery came from the other sources. The railroad grade acts as a containment boundary. Now we will look at these features in a bit more detail, including the State Road 50 entrance into the cemetery and Sansparilla Road area, where the view from below is very incisive to see the relative depth and locations of the ponds. Note that the North Pond on Commonwealth also flows into the Western Pond, where it ultimately discharges to the cemetery. We hope this 3D model provides an incisive view of the terrain, and we have this available for download as an interactive HTML. These views are focused on the SR 50 entrance into the cemetery and go under the ground and look up and hover the wireframe, so the water flow direction is clearly illustrated. These are wireframe traces of the entrance road into the cemetery at State Road 50, showing detailed plotting of the elevations. This continues for about 1 minute to show the details. Then we continue the wireframe traces under the road for another minute. Then it pans around the model and goes under Sansparilla Road. This model is available in HTML format for download and viewing on a web browser. The 3D model was developed using the USGS 3DEM LiDAR in a Python script written in Google Colab and the Plotly interactive 3D function, which can handle about 1.5 million data points. These are wireframe traces of the entrance road into the cemetery at State Road 50, showing detailed plotting of the elevations. This continues for about 1 minute to show the details. Then we continue the wireframe traces under the road for another minute. Wireframe traces continue until the end of the video to provide high-resolution details.
This is an Apple Maps 3D view of the Longleaf at Oakland single-family subdivision in the town of Oakland, in Orange County, Florida. This subdivision was constructed in 2018-2019, and it is adjacent to a cemetery. There was a high-intensity rainfall event between 7 p.m. and 9 p.m. on Sunday, September 27, 2020, which led to standing water in the cemetery. There was and still is a misplaced belief that this standing water emanated from the new subdivision. A deep analysis of rainfall data and further investigations have disclosed that this standing water in the cemetery did not emanate from the Longleaf subdivision, and in fact, not a drop of water came from the subdivision into the cemetery. The deep analysis of the rainfall data indicates that the rainfall event from 7:30 p.m. to 9 p.m. on September 27, 2020, approximately 5.3 inches of rain, was by far the most intense short-duration rainfall event experienced at this site since detailed hourly records have been kept going back to January 1st, 1995. The standing water in the cemetery emanated in large part to the discharge from the Commonwealth Pond to the east of the Pulte project. It was designed and constructed many decades ago with flawed calculations, which undersized their stormwater retention pond. This image shows the 2 radar rainfall pixels at the Oakland cemetery site. These tables contain a first-time analysis of the 2-hour, 3-hour, 4-hour, 6-hour, 24-hour, and 48-hour cumulative rainfall totals from the St. Johns River Water Management District radar rainfall pixels specific to the Oakland cemetery, going back to January 1, 1995. The analysis was performed in a Python script, and the results show that the September 27, 2020 rain event was the most intense since records have been kept. The data shows that the Hurricane Milton event was the biggest 24-hour or 48-hour storm at this site since 1995, and the cemetery did not have any standing water due to the diversion of the Commonwealth Commercial and the SR-50. These observations confirm that the Pulte project did not source the water observed on September 27, 2020. These images are taken from the National Cemetery Archive and was taken after the September 27, 2020 storm event and show water entering the cemetery from State Road 50 at the cemetery entrance road. They show sandbagging at the corner and a flow line showing how the water came into the entrance road, crossing over the caskets and eroding the sand. This entry of water into the cemetery was subsequently fixed at the time of Hurricane Milton, and there was no water entry during that storm.